Okay, let's continue from for chapter 14. Uh, let's start with this one. Maybe I'll give you 5 minutes to read this. Okay, did you get the answer for the first one? If you die, what's wrong with that? Minus, should be -4, right? -4 and 1. Yeah, yep, that's correct. So, uh, where is it?
Coconut. Coconut. Hello. Uh, how do you get -4 and 1? I cannot. Okay, and then wait, take a picture.
Oh, sorry.
Yeah.
That's. Can you hear me?
Yes, I guess.
Okay. So it's from the first derivative, right? So you can
Oh.
equalize the first derivative of x and y to 0 here
Mm,
to find two equation.
mm,
Then you can eliminate using substitution or elimination to find x and y. So in this case, I multiply this one by 2. So this equation become this one, and we can eliminate the y here.
oh yeah. And then find x and y. Okay.
Find x, right?
Mm,
This one x is -4, and substitute this back into the second equation.
mm.
This one. So this goes here and goes here. Okay.
Okay.
Sorry, I forgot to turn on my mic.
It's okay.
Okay, and so for then we need to check for our second derivative, right?
Mm,
So we have to find the t here, which is fxx and fxy minus fxy squared.
mm.
So fxx is derived this one again in respect with x again. So just 2 here,
Yeah.
just 2, and in respect with y, in respect
2.
with y again, just 2 again, and xy is -1. And the t here you get is 3, right? When the t
Mm-mm.
is greater than 0, then you have to check for the fxx. If fxx is greater than 0, then it's local minimum, and if
Mm,
xxx is lower than 0, then it's local maximum.
mm.
If b is smaller than 0, then it's saddle point, right? It's saddle point.
Okay.
And if b is equal to 0, it's just no conclusion.
No con-
So you cannot decide if it's local minimum, maximum, or saddle.
Okay.
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 Do you have any question again for this one?
If like 2 for the fxx, that one is if 2 greater than 0, isn't that the local minimum, or the 1 is local minimum?
Oh, sorry.
Um, like after we find the fxx,
Yeah.
we find 2, right? Is that the
Yeah.
local minimum
Oh,
or
no.
no?
This one is for checking these points. For this
Oh,
case, there is no x or y here. But for the next question, I think you have x and y. So you have to put x and y, this these points here, back to the
uh,
fxx and fyy. This one
oh,
is for,
okay.
only for checking this point, if it's local minimum, maximum, or
Oh,
saddle
I
point.
see. Okay, I got it.
Okay. Okay.
Okay, great.
You have any question? Okay. Is it clear?
Clear.
Okay. Let's move on to the next question. The next one. Let me write. So
fx
fxy is x squared plus y times e power of y over 2. So first, like the previous one, find the first derivative of x and y, fx(y). This one just consider this one as a constant, right? So just derive this one to x times e power of y over 2. And for the derivative of y, you have to use a product rule here. So derive this one first, 1 times e power of y over 2 plus this one, x squared plus y, and derive this one. This one is just half times e y over 2. Okay. And let's just find the second derivative of this one first. Fxx is just 2 e y over 2. Fyy is just derive this one just half e y over 2 plus use dot product again for this one. So half e y over 2 plus x squared plus y times half times y over 2. Or we can simplify this one with e power of y over 2. This one plus this one, right? Just become 1 here. And plus 1 over 4 x squared plus y times e power y over 2. Okay, for this part. And we can, just like previous one, we can equalize both of these with 0 to x e over 2 equal to 0. From this one, we can see that the x is equal to 0, right? Because whatever the value of y, if you want to equalize this one with 0, you have to get x is equal to 0. Okay?
Oh.
And for the second one, let's move on to the next page. E power y over 2 plus x squared plus y equal to 0, and this one is 0 from our first equation. So this one is times a plus y, so plus this one is y times of y over 2 factorized to e power of y over 2, and we can see this one. So y over 2 minus 1, so y is minus 2 here. Okay?
Okay.
Because this one will never be 0, right?
And let me
Okay.
see.
And then we get this point, right? The point is 0, minus 2. So we have to check for our second derivative. Fxx is 0 to minus 2 over 2. So put these points to this equation, fxx minus 2 over 2. So this one is 2 over e. And fyy is 1 over e plus minus 2 over 4 times 1 over, and you can multiply, get the t here, multiply this one. Or we can say this one is minus 1 half e minus, oh, we haven't searched for fxy, so it is this one, then this one just became, we have this one with x, so 2 over 2 times x, so this one just a x e over 2, put the 0 and minus 2 here, so this one is 0, 0 squared, so you can cancel this one, so this is this one is 2e squared minus 1 over e squared, so this one is 1 over e squared, which is greater than 0, right? The t. And we
Yep,
can
yep.
see here fxx, our fxx is also greater than 0.
Local minimum.
So yeah, this one is local minimum for this point, 0 and minus 2. Okay,
Oh,
you have any question for this one?
no, it's okay.
Nope. Okay, let's continue for the next part. Lagrange multiplier here. Maybe I'll give you 10 minutes to do this. Okay.
Aku mau kok.
Okay. Okay. Did you get the answer for the first one?
I got if x equal to 0, 0 plus minus 1.
Number 59.
Yeah.
I think that's not correct. Yeah, that's not correct. Let me. Okay. Okay. Let's discuss this one. So for the Lagrange, we have our function and our constraint, right?
Mm-mm.
So the Lagrange multiplier is what is it? The first derivative times this one is Lagrange multiplier times g1. So partial derivative of x is 2xy, and partial derivative of y is just x squared here. It's equal to this one. We have this one with x, 2x, and 2y. So you get two equations, right? 2xy is equal to lambda 2x, and x squared is equal to lambda 2y.
Yeah.
Okay, so from this one, you can just cancel this one. So the y is equal to lambda, and substitute this one to this one. So x squared is equal to 2 lambda squared. Substitute this one and just put it back here. So our first constant is this one is equal to 1, right? Equal to 1. So our x squared, you can change this one with 2 lambda squared. So 2 lambda squared plus y, can substitute this one again. So this one is just lambda squared is equal to 1. So 3 lambda squared is equal to 1. So lambda is plus minus square root 1 over 3. Right. And we can just substitute this one to this one. So the y is also plus minus square root 1 over 3. And the x squared is yes, 2 times lambda squared. So this one 1 over 3. So x is plus minus square root of 2 over 3. Okay, and then we need to check for all of these combination. So x, y, x is 2 over 3. This one can be plus minus, right? Because our function is x squared, so it doesn't bother with the sign here, plus minus. And y is can be plus square root of 1 over 3 and minus 1 over 3. So fx xy, we can put these points to our initial function here. So we can get this one is plus 2 over 3 square root of 3 and minus 2 over 3 square root of 3. Where this one is a maximum value and this one is minimum value. Okay. So for a maximum value, we get this point plus minus square root of 2 over 3 and square root of 3 max. and the minimum value is plus minus. So this is our answer here. Do you have any question for the first one? Hello,
No, it's okay.
is it
I
clear?
did it differently.
Which part do you get it? You
No,
did it
it's
differently.
okay. I did the same, but like I also got like another answer, but I also got this one too.
Oh, okay, okay. Okay, for the second one, did you already done it? For number 60. So, and gx, y is x. So we can just have our first derivative. So this one is minus 1 over x squared is equal to lambda, derive this one, minus 2 over square 2. And 1 y squared is equal to lambda y over 3. And cancel this one, cancel the minus. So we can get x is equal to 2 lambda and y is equal to 2 lambda. And we can just put it into our equation again. So this is 1 over 4 lambda squared plus 1 over 4 lambda squared is equal to 1 again. So this one is 1 over 2 lambda squared equal to 1. So lambda is equal to plus minus square root of 1 over 2. Right? And we can just substitute this one back. So x is equal to plus minus 2 times 1 over square root of 2. We can normalize this one by multiplying with square root of 2 and square root of 2. So we can cancel this one, plus minus square root of 2. So y is also plus minus square root of 2. And then we have to check to put this point back to our first equation. So x equal to, when it's minus positive, this one is square root of 2. And if negative, then this one is become minus square root of 2. Maybe I can check this one. 2. And this one is minus square root of 2 and minus square root of 2. So this one is a maximum and this one is minimum. Okay. Have any question for the second one?
Sorry, can I see the previous slide?
Okay.
Okay.
Here.
Okay.
Okay. Is it clear?
Okay. Okay.
Okay. Okay. Let's move on to the third one. So number 61. Did anyone get the answer for this one? I think it's similar for your exercise in class, right? So, uh, x y c squared plus y squared plus c squared, and this one is equal to 3. So equal to 3. Derive this one with x, y, c is equal to 2x times lambda. Xc is equal to lambda 2y, and xy is equal to lambda c. And we can just rewrite our equation here. It became lambda is equal to yc over 2x, and lambda is equal to xc over 2y, and that's equal to xy over 2c. And we can equalize this equation, this one and this one, and this one and this one. So this one is yc over 2x is equal to xc over 2y. Cancel this one, cancel the c, and we can get y squared is equal to x squared. And for the second one, this one and this one, xc over 2y, xy over 2c, cancel the x and 2. So c squared is equal to y squared. And we can put that into the equation back here. So all in terms of y squared here. So y squared plus y squared equal to 3. This is 3y squared. And y is plus minus 1. And that's also same with x and y, x and c, sorry. So x is plus minus 1 and c is plus minus 1. And we can find all of the combination, which is x, y, c, 1, 1, 1, minus 1, 1, 1, 1, minus 1, 1, 1, 1, minus 1, 1, minus 1, minus 1, and etc. But the answer is always either 1 or minus 1, right? So it is when it's 1, so it's a maximum, and minus 1, it's a minimum. Okay? But you have to write all of these combinations when you do the exam.
So during exam, we need to write every variable.
I think yes. So 1, 1, 1, minus 1, minus 1, 1,
Oh,
minus 1, 1, minus 1, 0. And that's it. 1 minus 1 minus 1. So if this one is max, and the one with 1, 1, 1, 1, and etc. is minimal. So I think you have to write all of this. Okay.
oh, how do we know like if that one is like max, the
When the value is, I think, is the maximum, or is it the highest
so
one? Yeah.
all the four red one has the same. Oh, that's why. Oh, minus becomes
Yeah.
plus. Okay, I see.
All of
Okay.
the combination here is either 1 or minus 1, right? So it's either
Mm,
maximum or minimum.
yeah.
Okay. So for the last one, oh sorry, is it clear for the third one here? Number 61.
Yeah.
Okay. The last one is a little bit trickier. So 62. We have two constraints right now, right? So t x plus y plus c and h. This 2 is the constraint. So our function is this one, right? And so for these two constraint, we can just write this one. We can use two variables for the Lagrange multiplier, or two Lagrange multiplier, which is lambda and mu here. So let's just derive this one with x. So 2x plus lambda, so 2x is equal to lambda times derivative x, partial derivative of x.
One.
This one is 1, right? Plus partial of x, this one, just also 1 again, times mu. And derive this one with y, for y equal to derive y, 1 again. Oh, sorry, this one is minus mu. And derive this one with c, 6c equal to derive this one with c again, 1, and plus 2 mu there. So we can get these three equations, right? 1, 2. And we can just let's move to the next part. We can just write the equation again with this one. X is equal to lambda plus mu all over 2. Y is equal to lambda minus mu all over 4. And C is lambda plus 2 mu all over 6. And we get this equation. We can substitute x and y, x, y, and c here. So this one is lambda over 2 plus mu over 2 plus lambda over 4 minus mu over 4 plus lambda over 6 plus 2 over 6 lambda is equal to 1. Can use this one as all over 12. So this is 6 lambda plus 6 mu plus 3 lambda minus 3 mu plus 2 lambda plus 4
4
mu
mu.
all over 12 is equal to 1. And we can simplify this one with, so this one we can 11 lambda plus 7 mu is equal to 12. So this is our first equation. And next one is from the second constraint, x minus y plus 2c. So 2c is equal to 2. So like the previous one, we just substitute all of x, y, and c back. Lambda over 2 plus mu over 2 minus lambda over 4. This one is minus times minus, so it's positive mu over 4 plus lambda over 6. So this lambda over 3 plus 2 lambda over 3 is equal to 2. Again, equalize the bottom part with 12. So 6 lambda plus 6 mu minus 3 lambda plus 3 mu plus 4 lambda plus 8 mu all over 12. Simplify this one, so this one is 6 minus 3 plus 4, 7 lambda plus 6, 6 plus 3, 17 mu is equal to 24. So this is our second equation. Write the first equation again, so 11 plus 7 mu equal to 12, and 7 mu plus 17 mu is equal to 24. We can eliminate the lambda here, multiply this one with 7, and multiply this one with 11. So 77 lambda plus 49 mu is equal to 84. 77 lambda plus 187 mu is equal to 264. Eliminate the lambda minus. So this one is minus 180. This one is minus 138 mu. So mu is just 180 over 138. Divide by 6. This one is 30. This one is 23. So 30 over 23. And substitute this back into our first equation here. So 11 lambda plus 270 over 23 is equal to 12. 11 lambda is equal to, multiply this one with 23, to 76 all over 23 minus, this one is 210 over 23. And this one is 66 over 23 is equal to 11 lambda. Lambda is, this one is 6. So lambda is equal to 6 over 23. We can get the mu and lambda, so we can get x, y, and z again. So x is 36 over 23 times half. So 18 over 23. Y is minus 24 over 23. This one 6. So this one minus 6 over 23. C is 6 over 23 times 1 over 6. This is 11. So 11 over 23. So we can get these points, right? So this is our points. Can put it back into our first function. Where is it? Our first function is this one, right? So f x y c is 324 plus 732 plus 360 all over 529. So this one is 259 all over 529. And we can check for another point for our reference if it's maximum or minimum. So we can check with another point, and we have to check with points that satisfy both of these constraints. So we can check it with 0, 0, 1, because if we check it with the constraint 0 plus 1 is equal to 1, and 0 minus 0 plus 2 is equal to 2. So this one is our first constraint, second constraint. And if we put it into our function, this one is just 3, right? And this one is lower than 3, right? It's around 1 point something. So our point here, what's our point? 18 over 23 minus 6 over 23 and 11 over 23 is our minimum.
Oh, so for it, that one like 001 is like just for checking.
Yeah, just for checking our points here. It's if it's a minimum or maximum.
Oh,
Okay.
okay. So you can also plug 002.
But 002 doesn't satisfy the constraint here. If you put it 0,
Oh,
2, then the first constraint is 2, right? Which is not equal to 1. This
oh,
is this constraint. Oh, sorry. This one is equal to 1 and this one equal to 2.
oh, okay. I see.
So you have to find a point that satisfies both of the constraint to check it.
Oh,
Okay?
oh, wait. So that one 002. Is it can we put the second constraint with 1, or is it supposed to be 2?
Oh no. The 2 here is from our constraint, right? The constraint is, where is it? 2C here.
Um,
The constraint, sorry. Constraint is this one, right? So if I put 0, 0 and 1, so 0 minus
oh,
0 plus 2 times 1.
yeah. Oh, I see.
Okay?
Uh,
Okay, do you have any question for the Lagrange multiplier here? Find the maximum and minimum. Actually, I think the time is up, right? But actually, I have one more question about the chapter 15. But maybe we can just skip it and continue on the next week. So, okay, if there's no question, and that's all for today. But do you have any question
right.
for chapter 14? Nope. Okay.
Nope.
Okay.
Oh,
Thank you, everyone.
so can I say chapter
Okay.
15, sir?
Oh,
Take the
this one.
picture. Yeah.
Okay.
Thank you, Ko. Okay.
Okay. Thank you.